Hi, my name is David Torres. In this demo, I will showcase how to deploy environment-based infrastructure. Who am I after all? I am a Linux system specialist, and I am also one independent cybersecurity researcher. Currently, I work as a full-time DevOps engineer with focus on rebuilding, redesigning, and securing legacy infrastructure. I also work as a consultant and incident responder. Over the past year or so, I contributed to many open source projects, mostly related to Linux, systems, or cybersecurity. I also coordinated the dismantle of a malware infrastructure after one incident response job. And often, I create tutorials, cheat sheets, and walkthroughs related to Linux and hacking. This demo is divided in 10 sections. In each section, basic fundamentals will be discussed and applied step by step. The main goal is to provide the knowledge and the familiarity, so anyone can achieve the same result. In section 1, we will deploy a VPC with network segmentation, taking into consideration availability zones. In the section 2, we will deploy a single VPN server that will be one entry point to the VPC so we can deploy all the other assets. In section 3, we will deploy a DNS server that will protect users of the VPN server against known malicious domains. In section 4, we will deploy one XDR that will be used in future sections. In section 5, we will deploy one application load balancer with wildcard auto-renewed certificate. In section 6, we will use the power of automation to deploy application, audit, and configure hosts. In section 7, we will replace the single VPN with a highly scalable VPN cluster. In section 8, we will deploy a monitoring server that will watch the health metrics of all the servers. In chapter 9, we will revisit the XDR, we will register nodes, and we will analyze telemetry. Finally, in section 10, we will deploy a Kubernetes server with continuous integration and continuous deployment capabilities. No matter what's the cloud provider, the first decision to be made is where the production environment will be running. Ideally, it is as close as possible to the clients being served for better throughput and lower latency. For this exercise, I chose Ohio as the production environment region of my choice in AWS. It has 3 availability zones, but I will use only 2 because the amount of high availability resources is a requirement of the organization and the applications it run. So for this exercise, I decided for 2, and I prefer to use one region for production and another region instead of another VPC in the same region for the non-production environments, because it's easier to set IAM roles and policies for resources and developers to be confined in a single region, and for maintainability because it's easier to look at assets like EC2 instances and don't see production and non-production resources all together. AWS create one default VPC for each region and one subnet for each availability zone to start with. I deleted the availability zone C. I will be using only A and B, and I properly labeled the resources accordingly: production VPC, public subnets 1 and 2, public route table, and in production internet gateway. The first network segmentation we will be doing is segmenting what is the public and the private subnets. The public subnets are for those resources that need public IPv4 addresses and will connect to the internet through the internet gateway. And the private subnets will use a NAT gateway with a single share public IPv4 for internet access. First, I will create the two subnets. Private one will be in the same availability zone as the public one. And they will all have a /20, which provides up to 4096 IP addresses, which is more than enough. Okay. The next step is create the route table for the private networks. Okay. Then in the subnets dashboard, I will select the private subnet one first, and I will associate with not the public route table anymore, but the private. Same for private subnet 2. And I will create the NAT gateway to provide internet access. The NAT gateway has to reside in a public subnet, so it will have access to the internet, and I will allocate a public IP. This is going to be the one ends with 87. While the public route table identifies anything in this IP address block as local traffic, anything else goes to the internet gateway. But the private route table for now only has decide what is the role for the local traffic. What we have to do is create a last resort default gateway to the NAT gateway and select the NAT gateway that we just deployed. Back to the VPC. Private subnet 1 goes to the private route table to the NAT gateway. Same for 2. And the public subnets are not changed. Let's test the newly deployed infrastructure. On the EC2 dashboard, before I deploy servers, I want to point out the security group roles. By default, there is a security group that AWS already created, and the outbound role does allow unrestricted access to any destination, while the inbound has only one row that allow all traffic as long as the source is the security group itself. So all the resources that share the same security group will be able to communicate with each other, but I don't have how to connect from outside the VPC into any of the servers that I will deploy. Let's go to IAM, and I will create a role that will allow me to have a terminal session on the EC2 instances. EC2 is the type of resource that I will attach the role to. The role will have a single policy, which is good for this test. SSM full access will make sense in a bit. I will show what session manager means. This is the title. Allow session manager. Create. Really? Back to EC2, I will deploy the first instance that will be called private instance. It's very slow. Private one is good enough. The base image will be Ubuntu. The instance type or the size is going to be a T3 micro, which is a burstable 2 virtual CPUs, 1 gig of RAM. It's good enough for a ping. I don't have any key pair to associate because I won't do any SSH connection to it. I have no network connectivity to it. This is going to be in the private subnet 1 because I just called private 1. Yes. Then the security group will be the default. And here is where the allow session manager role that I created comes in place. I will associate this profile, this role to this instance and deploy the private one. I will deploy another instance. Public one. Same thing. The only difference will be the network that I will deploy on. Oops, it's scrolling super fast. Now it's going to be in the public subnet 1. Default security group. And the session manager. As you can see, this server public one that was deployed in the public one subnet has a public IPv4 address attached to it, while the other won't. I will copy the private IP. And I will go to the other instance, private, no public IP. I will connect, and this is the session manager. That's why I can connect to it and get a terminal session in it using the AWS console. and I can ping. Another important thing to have is a private hosted zone for a domain that's only resolvable inside the VPC. I will call prod.vpc. I'm saying it is a private zone that lives in Ohio in this VPC. Then I will create a record like if it was a subdomain, public one. And I will go back to the EC2 dashboard. I will go to the private again. That has no IPv4 because now I will do another test. So I can ping public one.pro.vpc server because I created a record to resolve to the IP that I have pinged just before. And I will also get what's my online IP address. Notice that it ends with 87, which is the one attached to the NAT gateway. In summary, what we just deployed were two EC2 instances, one in the public subnet and the other is in the private subnet. While they could communicate with each other with their private IP addresses or the private hosted zones that resolve to the private IP address, the only difference between them is that to have access to the internet, the private one server had to hop on the NAT gateway to reach the internet, while the public one server had direct access to the internet. For the next step, I will deploy a single VPN server that will be used to have a foot in the door inside the VPC to deploy other infrastructure servers. But later, this single VPN server will be terminated and replaced with a VPN cluster that's going to be elastic. To start, I will create a security group that will allow inbound connections only for the OpenVPN protocol port under UDP. Inbound rules, add a rule, UDP 1194 anywhere. Outbound, no change, all allowed. Now we will deploy the VPN server itself. Ubuntu will be the base image. The instance type can be a burstable small, D3 small, 2 CPUs, 2 gigs of RAM, just because there's not much of CPU or RAM demand, but much more of network throughput. It has to reside in a public subnet because it needs a public IP, otherwise I couldn't connect to it. The security group was just created. and the session manager so I can connect to the box and issue comments. The public IP ends with 111, just to keep in mind. Sometimes it doesn't show up right away. The trick is to go back and forth, and it's there. This command will download this installation script under this name in the current folder directory, set it as executable, and run with sudo. The instructions are simple. This is the IP, the public IP that clients will use to connect. I will, in the future, in the next few recordings, I will use a domain name instead of one IP, so the infrastructure could be elastic and have multiple servers behind the same name. For now, it is correct. I will use the recommended option 1 for UDP, default port, and current system resolvers, which means it's going to use AWS Route 53 to resolve names, which is necessary to resolve the prod.vpc, the private hosted zone that we created. Client name, just client, it's good enough. Takes 10 seconds or less. Okay. There is no problem to share this in the recording because it will be destroyed in a few minutes. This is how the OpenVPN configuration file looks like. It is a client type of configuration. It will create a device called tunnel, protocol, IP, and port that the client will use to connect to the server. There are other things here that can be tweaked to have different configurations, such as allowing multiple connections with a single configuration file or other necessary things. For now, this is what I need. All of these things are keys and certificates I didn't mention, but just believe it's there to the authentication. It's not a password-based VPN. In my local computer, I will recreate that file, ovpn, client.ovpn. I will paste the content of the file, except for that. Yep, it's all here. And I will use the command line openvpn command to establish the connection. In another terminal, I can see that there is a ton interface. This is my IP inside the VPN. I can ping the VPN server, so the tunnel is established and working. Since I forgot to delete from the preview exercise, I can even resolve that server that name for that server that doesn't exist anymore. And my public IP is actually showing to be the public IP of the VPN server. This is what the VPNs are meant for. And one more thing, we have also to add a secondary security group, not only what will allow the public internet inbound traffic to the OpenVPN, but also the one that will allow it to communicate with the other resources inside the VPC. Here is what's about to happen. Since I am connected to the single VPN server that I just deployed, I can reach any other server in the same VPC. So I will deploy two servers. One is a DNS blocker to protect users of the VPN servers against malicious domain names for tracking, malwares, phishing, and other threats. And I will also deploy one XDR that will be analyzing logs from the monitored hosts for behaviors that might match with the MITRE framework attack. Let's deploy the DNS server. Ubuntu is my base image. Computing power for DNS is minimum, so I might choose a single gig of RAM instance type. Now, I selected no key pair because I've used the session manager to place my key in the server, and I want this server to be located in a private VPC, the private subnet. Number one, no need for public IP. The security group can be the default. Where is it? For now. And because this is going to be a permanent server, I will enable deletion protection. No public IP. I will switch to root in this case, and I will run this command. This command will download in an installation script and pipe straight into bash. This is something that you should do with cautious. Do your own due diligence, check the scripts and everything, and I did mine. This installation is not extremely fast. performs all necessary checks to guarantee the installation success. Yep, I want to have an ad blocker. Cool, nice. It has one static IP. Yes. Okay, this case here, I have to guarantee it's going to, whenever it doesn't have the answer, it will ask route 53. So it's 127.31.02. That's it. Yep, twice. So I always enable this. This is a list of maintained by Steven Black's one unified list of hosts that are known to be malicious. Install web admin interface. Yes, please. Okay. Install all the required resource assets. Yep. Please log. Yeah, this is a privacy setting. We can have the extremely anonymized that will not log anything that any of the users do, and the other end is recording all the logs for what all the users access. As a reminder, this is a DNS server. The only thing it can do is resolve names. It can only record not exactly what they do, but everything the users resolve, and it does not know who resolved this or that domain. It only records how many, what were the blocked and the resolved, and that's it. It's just metric. I recommend to enable everything unless there is any other recommendation or policy inside the company for what can or what cannot be recorded. Okay, this is the temporary password. Can I select? No, I can't. This is the IP of the DNS server. I can check it out. And it's there. So I will go to route 53 and I will create a subdomain for that. Now if I visit with the domain, Google is letting me know that it's not HTTPS yet. We will get there. So I have the temporary password. I can log in. And this is what I meant that it logs. It logs the requests. I did a typo testing on my end, trying to troubleshoot. And yes, everything works. back to EC2. And the way to change the admin password is in the command line. So this is the command sudo pi-hole admin-p. Yep, I just set a new one. Do I get logged out? Nope. Yep, it's all up and running. The list of malicious domains comes from this feature here, Gravity, that can be manually triggered or via the command line using cron to do every day or every week as needed. And out of the box, it comes configured to only allow requests from the local network, since the DNS server is in the private subnet and the VPN server is in the public subnet. In theory, they are in two different subnets. So allow all origins and save. Now you're good to go. Later I realized that I type VPN instead of DNS. I hope you have spotted this mistake during the demo. Fixed. On the next step, I will deploy one XDR, which is a tool that will monitor the logs of the servers, looking for patterns that might reveal one attacker based on the MITRE ATT&CK framework. And this is just one overview. Feel free to search more about it and study this framework. Okay. We will also use Ubuntu as my base image, and the instance size will be a bit bigger than what I was using before. For now, I will use the 3 medium because I need 4 gigs of RAM to have a smooth operation. Again, no key for now. Network, it will be private subnet 1. Default security group. Hardware changes also for the disk size, the storage. Now it will make a database of logs, so we might need a bit more than just the minimum. And deletion protection, termination protection enabled. Switch it to the service account and issuing the command that will download. This is the current latest version as the time of this recording, and we'll execute it. The installation has finished. As you can see, the installation script is very clever and does all the dependencies configuration, the indexer for all the logs, and the server, the dashboard, everything starts now under a self-sign HTTPS, and this is the IP, the password of the server, the admin account. Again, I don't mind sharing because this will be destroyed before the release of this recording. So, okay, it's working. Meanwhile, I will get this IP. Oops. I'll get this IP. And I will go to Route 53 to create a subdomain that's only resolved inside the VPC for this service. And it works. Now the goal is to put a load balancer, one application load balancer, in front of the XDR and DNS web UIs to have public certificates and avoid browsers complaining for lack of security. Now we will deploy one application load balancer that will have pointed a real public domain, a subdomain actually, that will have certificate managed and auto-renewed or by AWS, and will be only available inside the VPC for the clients connected to the VPN to reach the DNS, XDR, and future web applications that will be sitting behind it. For now, the target groups for each one of them will have only a single server, but could have multiple. I will create a hosted zone that is called prod dft.1. It is a public zone. In fact, the zone is actually public, but everything it will resolve is internal address. So the private IPs will not be routable on the internet anyway if someone queries and get the private IP for that resource. Here are the configuration that I have to apply to my domain, which is this domain, for this subdomain as a new zone in Route 53. Since my domain lives in Cloudflare, I had to create one record NS type for prod.mydomain that points to one of the servers of Route 53. In production, I would actually create 4 rows, 4 records, one for each. It might take a little bit to propagate. Meanwhile, I will copy the domain. I will go to Certificate Manager and I will create a wildcard certificate. Public certificate. It will be star dot. I could have multiple. I could even have in the same certificate up to 3. It's gonna be validating via DNS, the algorithm for the generation of the key and certificate. No need to change. I will go to the certificate that I just created. These are the 2. Could be even different domains. And it asks me to create a CNAME pointing to these values here. I can use this single button to speed it up. Since the hosted zone is managed by Route 53, there is full integration here. Not sure how long it's gonna take. Actually took less than 10 seconds. Now I will go to EC2 and I will create one application load balancer that will use that certificate. The type I will use is application. Application is for HTTP, HTTPS type of traffic, while the network load balancer would go by port and even TLS. And if you need one static IP, you would have to use the network load balancer anyway, even if it points straight to one in tandem with one application load balancer. It's sometimes important when you want to use the root of the domain, not any subdomain in it. It requires to be one A record, which has to point to one IP and not a name. Will make sense later. Yeah. Will be only internal, so no public IP to it. IPv4 only is good enough. I want to have it in a single. Can I? No, I think it has to be in 2. Private subnet 1, private subnet 2. I will leave in the default security group for now. I will not create any listener just yet. Web application firewall, it's very costly, but it's good. Okay, no spaces. And it will take a few minutes to... I have to have something here. In this case, let's do a dummy target group just to be allowed to proceed. So instance, this will be called dummy. For now, I will not add anything. Back here, refresh, select the dummy. The target group doesn't point anywhere. I will give it a few minutes because it is provisioning, and I will come back. There is a DNS name that's only resolved inside the VPC. Only served, actually. About 53. So these are the names that directly link to the servers themselves. And this is the domain that I will create a wildcard to point any subdomain to this address for the internal load balancer. It is a CNAME type. Try the star. Yep. So anything that goes to this address will actually resolve to the application load balancer. Back to EC2. Let's go to load balancers and edit our application load balancer. There is a listener, and we were forced to create a target for that listener from port 80 to the dummy. Dummy is just a single rule, which is the default for this listener, that for now doesn't forward anywhere. Let's make it forward to HTTPS. Instead of a target group, we'll redirect the URL, full URL, redirect. It will replace the schema, the protocol, override, but will maintain all the other arguments like host path query. In other words, anything that comes via HTTP port 80 will be automatically redirected to the same under HTTPS. Let's create the listener for HTTPS. I will put the same dummy target group so I can proceed and edit later. And I will select the managed certificate that we just issued with AWS. Let's test. I will force it to go via HTTP because I want to see the network redirecting to HTTPS. Here you go. As one can see, HTTPS now works. Let's do the same for the XDR. Now let's create the target groups to the services. It will be the type instance because we will select the instance in the target group. I will call it DNS target group. We know it is HTTP in the production VPC. Oh, good. Oh, no spaces in the name. Now I select the DNS server and I leave port 80 because we know the Pi-hole by default does not provide HTTPS. Confirming. Yes, the browser is saying it is insecure. So it's correct. Add. Below there are targets for review. Yeah, only one. Same for XDR. We know Wazuh created a self-signed certificate. We tested it before. Next. So select XDR and the port. Good to go. Let's add the rules inside the HTTPS port 443. The first rule will be for the DNS.prod.tft.1. This is just the name of the rule, but will also be the host header that I'm looking for. Whenever it matches with this host header, it will send the traffic to the target group, DNS target group. And we have to give a priority. In this case, can be any number between 1 and 50,000. I will give arbitrarily 101 and create. The second rule is for the XDR. Same thing, whenever the host header matches with xdr.mydomain, the target group now will be XDR. And here again, the priority. I can put any number. The idea is that the rules are evaluated in order. Ideally, the rule that has most matches should be at the top for faster response, and then it goes one by one. When nothing matches, it applies the default, which now is still pointed to the dummy. Means nowhere. It's a sinkhole. Okay, let's change it. Let's make it redirect any other traffic that doesn't match the first two rows to a centralized location, or redirect to URL, full URL, the root of my domain. It's a 301 redirect HTTP status. Save. right there. Let's check. Yes, it works for the DNS. Login page for Pi-hole. We can also inspect the certificate, which, as we know, it is a wildcard issued by Amazon. Same for the XDR. In summary, instead of connecting to the dashboards of Pi-hole and Wazuh directly with the pro.vpc domain, now the application load balancer takes care of the wildcard public certificate issued by AWS. Browsers won't complain anymore, and when the host header matches DNS dot or XDR dot, they are redirected accordingly to the target groups, and if none of these two rows are applied, the catch-all, the default row, will be applied and redirect to the original domain. Maybe you have noticed that during the demo, I selected the private subnets for deploying the application load balancer instead of the original intention of the first diagram. It doesn't make any difference at all in this context because whenever we deployed the ALB, we selected to be only internal use anyway. Even if I had deployed in the public subnet, it will not ever respond to any public request. It only exists and works inside the VPC. It's time to replace the single VPN server with a VPN cluster. Using outscaling groups, DNSs, and leveraging the other resources that we already have in our infrastructure. I have this code in my GitHub repository, which is actually a fork from the original one that Nir deployed a decade ago. I even have a pull request for suggesting some changes to the installation script and how it works, that anyone can come here and audit and see exactly how I did and why I did, and also see that there is no introduced malicious code at all. I will leave here because I will come back to it. First, I will go to Route 53 and I will create a placeholder for a domain that will be used by the cluster. It has to be public. Guess what? VPN. Just any number, any IP address, leave it there. This is the domain that I will use from now on. On EC2, I will deploy a new server. That I will simply call VPN. Once more, I will use Ubuntu as my base instance. The base image for my instance. The type T3 micro. The whole point of the cluster is that instead of just being scaling up, giving more CPU and RAM as the number of clients increase, I actually can deploy more instances of the tiny VPN server, which will aggregate not only CPU and RAM, but will also aggregate network capacity, because each one will have a gigabit or 10 gigabit network interface on it. No key again. I will place it in the public subnet 1. It will have auto-assigned one IP address. The security group will be both. The VPN has the default OpenVPN port allowed from anywhere, and the default makes it capable of communicate with the other instances and resources inside the VPC. Advanced details. I will enable session manager. For this one, I will enable deletion protection, because one of them will be always on, will never ever be terminated, and this one will be cloned and deployed in the outscaling group for additional instances of the service. Okay, this is my public IP. Let's put it here. Maybe it was enough time to boot. Let's see if I can connect to it already. I will not destroy the single VPN just yet. Yes, I can connect to it. Okay. This is in my repo. This is the installation script, my version of it. I will copy the link address. I will walk through the changes so it will make sense what I'm trying to accomplish. Download the file, mark it as executable, and run it. First change that I made in this script is now it offers not only the IP of the network adapter. I will cancel and I will show here. This is the IP of the network adapter. Now it offers to listen on any IP. In this case, I will select it. Stop here and I will show why. In the original installation script, it used the IP address of the network interface as the source address for the net for any traffic that comes from the VPN tunnel, but the destination is not the VPN tunnel, which is represented by this exclamation mark, would be translated using the source IP. Now, instead of using the source IP, it uses the outbound interface, and to do the translation, it has to know what's the IP of this interface. IP tables takes care of that. So in this case, no matter what's the IP for the clone, it will use it, and with the masquerade option for the net. This way, I can achieve the same goal without hard coding the network adapter IP in the route table. Another place where the IP address was hard coded was inside the server configuration. Now, with the option of binding on 0.0.0.0, this takes place in the configuration, and no matter what's the interface that the connection comes from, it will accept the connection as long as the credentials match. Back to the installation script. Let's add the domain, the subdomain for the VPN, vpn.prod.tft.1. I will accept the default for protocol port. Here is another point that the old installation script did not anticipate, which is the option 7, to be able to add a custom DNS resolver. In our case, we will use the IP of Pi-hole, the DNS server, but I will also, as a secondary, how can I say, in case the first one fail, this will use Route 53, the VPC resolver, the default one. Will not be protected against the malicious and tracking domains, but will be resolving, no downtime. This is another part, nothing really fancy in here. It just gives a summary before installing, saying where it is binding, protocol and port. I'm using a host name. This is the IP of this host name. This is the network interface that was used in the IP tables, and the resolver is a custom one. The installation doesn't take any longer than the original. Just few tweaks, and that's it. I will copy over the OpenVPN client configuration as I did for the other single server. The difference here for now is the domain, and later I will give some tips of options that can be added here to enable or disable some of the default features. Updating the client OVPN file, checking it's all here. Connecting with the new server now. Let's test network connectivity. Yes, my IP is actually the IP of the server, and if I do some resolve, let's say dns.prod.vpc, which is only resolvable internally, yes, this is the DNS server, works. Let's get out of this server. Let's go to EFS, which is not any other than NFS protocol, but with the E that Amazon likes to put elastic in all the names. What we will do is we're gonna call it VPN EFS. It will have a centralized location for the configuration of all clients. and will be mounted in the same location in all servers. And this way, the configurations, the keys, the secrets to connect for all new and revoked clients will be in sync among all the servers. It's provisioning, and here there is a cheat sheet how to mount it, but as you can see, it's been mounted with the command line, not what we want. We want it in the FS tab, so it will be auto mounted on boot, and that's what we are going to be doing there. Let me copy this, and let's go back to the VPN server in EC2. Now that I'm back to the VPN server, I will switch to root. I will create a directory at the root of the file system, which is called VPN EFS. And I will edit the FS tab to make sure this will be mounted on boot in all the servers that clone this server too. So what it means: EFS synchronization config among all VPN servers. This is that address that I copied from the newly created EFS. This is the directory that I just created. This is standard, just don't bother. If I try to mount, it will fail because it needs to have installed the NFS common. While it's installing, let me copy this. Yeah, finished. So just because it was asked for. Now I will go into etc and I will search for, there's too much in here, so I will search for the OpenVPN directory. Sits in here. Systemctl, I will stop OpenVPN server. Now I can mount. Does it mount? Yes, it does. This is mounted here. So I will move the OpenVPN directory to inside the new mounted volume. And I will create a symbolic link that will point to VPN, EFS, OpenVPN, and we'll have the name OpenVPN right here. So before we had the directory physically in this drive. Now it is actually a symbolic link to a mounting point of the EFS. Any other server that mounts this same location with the same configuration will start up the service with no problem at all. One thing that I want to do is create the image. I will call this image cluster AMI. If I leave this checked, as you can imagine, it will reboot the server. I don't want it to reboot right now. Okay, it's good. Version 1. And in a bit, this status will become available. Meanwhile, we can create a template. I will copy this image ID. I think it will be already there. But why not? So VPN cluster. This is the name of the template. If I click in my images, probably it's already there. That's the only one. The instance type, I will select a little bit bigger than the one that will be always on. This will be medium or small. The other was nano. Small. No key pair. For now, I will say use the public subnet one only. Oops, too fast. I will select the security groups, both. I will enable session manager again. And I think it is good for now. Might be. Later, we will leverage this user data, which is a script that we can run as the instance gets deployed. This is the launch template that outscaling group will use as a recipe to deploy more servers. There is only one template. It's currently in version 1, which is also the default version, latest default. Save. Okay, VPC. I will select both public subnets 2 and 1. I didn't need to have it set in the template, but because this will override anyway. No load balancer, no lattice, all fine. Desired capacity. I will allow it to be any number between 0 and 2, plus the always on, the one that never shuts down. The outscaling group can assume any value. For now, I will set the desired capacity to 1, so it automatically deploys as soon as I create it. and no changes to the policies that are actually the logic behind what instance should be terminated first. It's the oldest one or the newest one. I won't touch this just yet. Final check. Create. It's updating the capacity because the desired is 1, so it's deploying 1 for me right now. And meanwhile, what I will check is the EFS. I want to make sure the EFS is available in both availability zones that we have. Yes, it is in both. Otherwise, anything deployed on the availability zone 2 would break because it could be just in 1. I didn't anticipate, but the default saved me. If I go to instances, I will see one extra instance here that's being initialized. I could also see it from here in outscaling groups. This is this only one. Instance management. It's in here. This is the IP of this new server. Ends with 37. If I edit my VPN configuration and manually set, forcing me to connect to this new instance, just to make sure I am connected to what I want. Guess what? I am. So now I will create another role that I will apply to the outscaling group instances that will allow the instance itself to tell AWS what's its IP, what's its ID, to be added to Route 53, so the domain will resolve in them and they will accept new clients to connect. And also tell AWS, say, hey, I'm about to shut down. Please remove my IP from the DNS, and I don't want to get new clients, and it will monitor for existing connecting clients and only shut down when the last client leaves. So for now, we have allow session manager that has SSM full access. I will create another exclusive to service to the outscaling group, EC2. I will grant it the same manage policy as the other. It will be called VPN cluster role. It's in here. Now I will create one inline policy. I already have it in JSON. What does it do? It get hosted zone. It can change some records. It can list resources. It can update the outscaling group desired capacity. That's the thing. It's gonna tell outscaling group, hey, now you can reduce from 3 to 2. And by the way, terminate me, not random. Yes. So Ohio is US East 2. Probably I could put a star in here. The outscaling name is this outscaling group. And this I got from Route 53 as the ID for that hosted zone. Oh, I need to name it. Outscaling group Route 53. This name is not really important, it just shows in here, and this is the policy. Now that we have a policy, a new policy, let's attach it. We can give it to the launch template. We will create a new version. Modify template, create a new version. Advanced details. We will use this. So I will try to be as objective as I can to explain this script. What it does is it runs on the startup as the root user, just to keep in mind. It tells what shell it has to have to be invoked to interpret these commands. And I left this here just in case. Sometimes I deploy Pi-hole inside the VPN server. So as soon as it starts up, the image can be years old, but as soon as it starts up, the first thing it does, it updates the list of known non-malicious domains to be blocked. All of this thing here is the first command acquires a token. This token will be used for the next two commands, and one of them will try to get the instance ID from this endpoint here, and the other will try to get the IPv4. This is just a sanity check that prints out if everything is working. Of course, we won't see, but when we are developing the automation, it's important, or troubleshooting. So what it does right after knowing what's the instance ID and its public IP, it tells Route 53, this is the public hosted zone, this is the subdomain. It will tell, giving one identifier, which is its own instance ID, and tell the public IP to be included. It counts on certain amount of time. I don't know, if the shift in the company is 8-hour shift, I can start 1 hour before and 1 hour later, like 10 hours. So as soon as this VPN server is spun up 1 hour before the business hour, and it waits until 1 hour after. This scrolling is so fast. And tells the inverted information to Route 53, say, hey, by the way, at that same hosted zone, that same subdomain, find the record that has this instance ID and this public IP. But now instead of adding, please delete it. This way, this is inserting and this is deleting. This way, the first thing it does after the 1 hour after the shift, we assume people already disconnected. So the first thing it does, it removes the record from the DNS to avoid new clients to connect to it. But some clients can still be connected. So what it does is it keeps calling OpenVPN internally, looking for the absence or presence of clients. If there is clients, it will be printing to the screen, just for troubleshooting anyway.
what is the client that's connected, or how many clients are still connected. And as soon as this number is equal to 0, no one is connected to it, and no new client will come because the DNS record doesn't exist anymore. What it does is it talks to AWS, now telling outscaling group to terminate one instance. By the way, it informs itself its own ID. So instead of letting AWS to terminate any instance randomly, it's telling, please reduce the desired capacity, decrement desired capacity, and this is the instance ID you should destroy, myself. That's all it does. There are things that we have to change. We still have to enable the management for the OpenVPN. We have to do some changes to the IAM, to the image to allow to install AWS CLI. We have to make changes to Route 53. Let's see if I forget something. Okay, Route 53 first. Because there is only one entry for VPN, it has simple routing defined. What we have to do is set it to weighted. Weighted means it kind of does one load balancing with DNS. I can give, for example, I can say any number between 0 and 255. It's not a percentage. It's not like 50%, but I don't know, any number. I put 50 there in the script, so 50 here. They will all have the same weight. But for example, if I put 25 here, the always on will have half of the weight of the ones that only exist during business hours. This is important because the one that's always on maybe can be a less performant, or maybe during business hours we want the connections to go to the other servers and not to the always on. Keep the always on with lower number of clients, maybe because some clients connect very early and they only have this at their disposal when they connect early. So, and I have to identify it, so I will call it always on. Weighted 25, always on. Not here. This is the identifier, record ID. Okay. Now to EC2, let me go to the outscaling group and set the desired capacity to 0. Immediately the instance will be terminated, and it doesn't care if there is any client connected or not. It will be showing terminating soon. Okay, the always on here. Let me make a change to its name so we can identify it better. Always on. This guy can be retired. Yeah, single VPN. Yeah, so this is shutting down because of the autoscaling group desired capacity equal to 0. This is because I just asked it to. Let me connect to the always on instance again. Snap install AWS CLI Classic. Cool. The other thing is going to actually the location is here. I will add this to the bottom. And let me see the tips that I promised. This line will enable a management connection via telnet or netcat, as I did for the script, on port 7505. This will allow the same client with the same configuration file to connect from multiple devices at the same time. It probably needs to be in combination with this. In this case, I am commenting this line because this line stores in this file the IP, the internal IP inside the VPN tunnel for each client. So you have to comment this line if it's present. Otherwise, if two devices connect with the same client credentials, they will get the same IP. So comment this line, enable multiple connections, or disable multiple connections and leave one static IP for every time the client connects. Sometimes it's important to trace back network or to have logs or something like that. You can see here that this is the Pi-hole and this is the VPC resolver. This line can be commented if you want to allow your clients to use, I don't know, maybe the client connects to the VPN but wants to use Google or Cloudflare or Quad9 resolver. By commenting, it's being allowed. Another thing that, if present, is important to comment if you don't want to have any assignment for IPv6 for the tunnel. Sometimes it's interesting, sometimes it's not. My internet provider doesn't provide me one IPv6, and servers, hosts online that have only, they are rare, but if they only have IPv6, I can't access it. So if I live like this, I will get one IPv6 from within the tunnel, and I will be able to access IPv6 websites. I will keep this like this. I like to block, otherwise doesn't make sense. I'm placing a Pi-hole over there. Yeah, I think we are good to go. On the client side, there are also configurations that can be tweaked and improved. Systemctl. It's still stopped since last time. After mounting the EFS, I did not start it because I wanted to make sure I was connecting to the other server. And now I will start it. Sure, why not? And I will exit. I hope I have everything I need now. I will create the new image. That will be VPN cluster description. I don't want to reboot. This is my new image. I will say this is version 2. This name can never repeat. Yeah, so version 2. I will copy this image ID back to the launch template, edit once more. I created a second version. I didn't set it as default, and I am editing it again. Okay. At the top first, my images. Use the new one. Why is it so slow? Oh, here. Tags. I want name to be equal to VPN ephemeral. Hope I'm spelling it correctly, because the other is the always on. These ones will be ephemerals. And I will set the default version to the latest, which means now that I set the desired capacity back to 1 or 2, why not? Let me click here. It also says it will always use the default. That's why I changed the default to point to the version 2. Otherwise it would spin up the very same. Let me get 2. It's going to start route 53. We only have 1. I put it here. Will not be long until we have 2 more added. This is the one identified as always on. Has half of the weight of the other 2. Actually, it did not work, but I know what it is. Back to EC2. Launch template. This is the original, the version 1. The version 2, I added the new row to the EC2 instance, but when I created the third, I created on top of the 1. So I need to apply the same change to the third, actually creating a 4th version with the proper row that I messed up. allow session manager, needs to be VPN cluster role. It's the new role that I created. This will give me the chance to demonstrate one thing that's very interesting about outscaling groups. If there are software versions that get upgraded from one version to another, as soon as I place a new image, create a new version of the launch template, whatever is running is still running until they terminate and others, new ones will come, but not to replace. They will come when they come. But there is instance refresh. I can create here a task, launch before terminating, terminate before launching. Doesn't really matter. I will ask to terminate first. Yeah. Instance warm up. Who says I remember everything? Because I don't. Let's see. It will tell me the progress, but I can also, oh, successful. Cool. What does it say here? The two ephemerals are still here. I don't think they were recycled. If it sees that the version of the template is exactly the same, it might not. But I think I did change. Did I set? Ah, I did not. Now we have a version 4, but the default is still 3, so it says, nope, everybody's the latest. No, that's not what I wanted to do. Okay. Set default version to version 4. Yep. We still have 2. The 2 are here. One ends with C, the other ends with 7. I will watch this. Same thing. Instance management. Yep. One is terminating. Another one is coming up. And already in service. The other is still terminating. Where's the 4th? Yeah, it's coming. Let's go back to Route 53. Let me filter for better visualization. And it works. These are the 2 that came from the outscaling groups with weight of 50. These are the instances IDs, and this is identified as the always on. Since I know this instance after started, they will count down as many hours as I programmed them to, and will self-terminate. I just need to worry about starting them. So I will do I can say business hours will be 2. Every day. I am no. I am at the same time zone as New York. No. New_York. In my time zone will be 8 because the team starts at 9. Let's say the minimum will be 0, the max will be 2, and maybe tomorrow is the date when it starts, and then I can create it. Is there? No, there's not something like business days. Like, yeah, anyway. This will take care of spinning up those 2 instances, and they will self-terminate at the end of the day. This is how it looks like. These 2 are ephemeral ones. This will never terminate. It's termination protected. This is serving just for the clients of the VPN servers for filtering malicious DNS. Later we will be tweaking and installing XDR in all the instances. So the outscaling group instances, they are one image spun up using a template by outscaling group. They all have mapped the configuration for the OpenVPN from one network file system called EFS in AWS Universe. I encourage you to check out the pull request that I proposed the changes to the OpenVPN installation, the original one. And there is also a new script that you can check out. It allows one to create and revoke users with a single command line, not going through a menu answering options. The idea is to make possible to create automation and also to trigger this script via Ansible or Terraform, for example. And if the user account is not just the username, but the username at the domain, which means the email, it recognizes and sends the configuration to the client email at the account is created. So take your time, check it out. Also encourage you to contribute to the open source applications that you like and use regularly. So far, everything that was done was manually through the AWS console, the web UI interface. We will start doing some automation. We will deploy a DevOps server that we will use for running Ansible playbooks from. And we will also restrict SSH connections to any of these resources only when coming from the playground of the DevOps. I am connected to the VPN, to the always on server. The ephemeral ones, I set the desired capacity of the outscaling group to 0 because I am the only user. I will call this server DevOps.
1 gig of RAM is good. DT micro. This server will be in the private subnet number 1. No public IP. Default to security group. A little bit more of storage. Allow session manager. Enable termination protection. Oh, forgot to say no key. I'll start cloning this repository that I created with very generic playbooks to start with. Do I have git? Yes, I do. Git clone this. Let me rename this. Will not be a template anymore. In here I have a menu that is simply a help for executing the .run shell scripts, Control C, and each shell script is actually, let me show how it looks like. It simply sets variable for the target, the Ansible service account password, because even if we keep the SSH key inside this server, it always requests the password to elevate privileges in the target hosts for as a secondary factor. For SSH establishing connection uses the key, to elevate privilege to have sudo privilege to execute anything, it asks for the password as a second layer. Then it executes the playbook with the target, passing the credentials. And check is actually a dry run. And since the dry run is completed, just hit enter and it executes again for real, not dry run anymore. If any of them fail, it will print out saying failed. There is this script here that only has boxes, and it shows pretty nicely exited, failed, dry run, and run. Just fancy looking console thing. Do I have tmux? I probably do. The menu looks ugly anyway. Firewall. Do we have UFW installed? Yes, we have it installed, but it is inactive. First step will be to enable it, because we don't want anyone to connect to this box in any way. This should be a standalone, no inbound traffic at all. Only outbound connections will be allowed to reach the other resources, not this. This is interesting if you use the session manager to hop on this box, and AWS can log all the commands typed by all the administrators that use session manager. It can log and send the logs to one S3 bucket. This is a way of auditing and making sure everybody knows everything they type is being recorded and can be verified later in case of something happens. Let's leave this way. Now that it does not allow any outbound connection, what I will do is I will create SSH keys for it. So the comment will be Ansible. First, it asks where to save. Yeah, default location. Password phrase for the key. No, I will leave without for now. If I cat the public part of the key, this is what I will add to all the servers. First, let's go to DNS. I will add one user called Ansible. I will give it a password. User modification, I will add it to the group sudo. So it will use the password that I just set to become root. I will create the default location for the keys. And I will add this key as authorized to SSH here. Let's see if it works. SSH DNS pro.vpc as the Ansible user. And it does. So sudo ls will prompt me for the password. Yeah, it works. So far, so good. XDR server. Adding it to the sudo group. Switch into it. mkdir same thing. Checking. All works. Oh, not here. The last one. Am I in the same server? Probably I am. Yeah, sorry. I meant to click on VPN. XDR DNS VPN. Yes. What the heck of character is that? Okay. Switch into Ansible. Sudo ls works. So mkdir let's add the key to exit the server before I test, because I don't think I have a local name for it. I think I have for the XDR and DNS, but not for the VPN. Let's check. No. VPN, which is actually the always on, not the cluster itself. Okay. Now back to the DevOps. apply SSH here now. Yes, I can. Let me install Ansible and also create the inventory. Now let's edit the inventory file. Ansible. It's not auto-completing. I created the directory and the hosts, the inventory file. In here I will do servers, and I will add the names dns.pro.vpc, xdr.pro.vpc, vpn.pro.vpc. I will add some variables. Servers vars, Ansible user is Ansible. Hope there is no typo. Let me see if I can execute any of these playbooks. Audit. Yeah. Oh, my target, the password for Ansible to elevate privileges. It's doing a dry run. What just did is it checked for first information gathering, then it checks for the host name. In this case, this audit makes guarantees and applies if someone changes. The host name of each box will be exactly the name that I want to call it with Ansible. Will make a bit sense in a bit. It checks for the hosts file because we can have a shared hosts file for common names, but we use Route 53 for that. It's a bit out of order because I configured Ansible to, the playbook is configured to do in parallel as many as possible, as fast as possible. It doesn't go one after the other, it does everything in parallel. It checks for the firewall, it makes sure the firewalls are enabled, it sets the timestamp. I think it sets the time zone. I don't remember. Yeah, the time zone is here. I can apply. Hope I don't break anything. I don't remember what this playbook does. I roughly remember. Even though the first part looks like all out of sync, in this case it looks in sync, like doing all three per task. Seems like it looks good. So for example, all of the servers had this name that was auto-generated by AWS with the IP in the name. So what that playbook did was, in another words, sudo hostname ctl setting the host name. In this case will be DevOps. Is there any typo? Probably not. I can't use the errors. If I go back, Now I see the name has changed. Let me see in the other servers if the name has also changed. Of course it has, but let me see what else I changed there. Okay, XDR. Yeah, the name looks good. The time zone is in my time zone. I didn't set it manual. Ansible did it. Yeah, looks good. Oh, UFW status. So for now, it does, before enabling the firewall, it added a row so it would maintain persistency. Otherwise, I would enable the firewall, and next time I would not be able to connect to it with Ansible. So it did allow from anywhere for SSH. But if I try to connect to XDR, will not work. It needs to enable sudo w enable 443. Oh, not enable, allow. Where is it? XDR. Yeah, now it works again. Let's go to DNS. Same thing. Doesn't load. Now it does. These two ports are specific. One server is port 80, or another server is port 443, and the other server in the inventory, which is the VPN, has to have port UDP 1194, otherwise I will get disconnected. Next time I can't connect again. They are not in the playbook because they're specific per server. What is common is port 22 for SSH, that we would do some tweak in a bit. Works. Get out of here. Back in here. Let me go into, let me edit the playbook for audit. YAML. Source, that's what I want to change. The source IP, I want SSH to be only enabled, allowed when connections come from the DevOps server. I don't want it to be available for any user of the VPN that will connect
since they are inside the VPC, they can reach all the servers. Yes, they can. But the SSH will only be allowed from the DevOps server, which is this. /32. Is it anywhere else? No, the playbook is all that it is. So there is a hosts file present in each server. Every Linux has, but we can manage from a local place if we want. So if you look at this, there is a file here called audit hosts. This is the hosts file that can be common. I can add here, for example, always resolve to this name, and then I would break Google. And if I save here and run the playbook, this will be updated everywhere. This could be a way of blocking some asset, for example. I will not use it for now. Let me go to the menu again. Let me run the audit, which is number 3. Yes, target all. Ansible password, a dry run. So the host name, no changes at all. The only thing that has changes there is the firewall. Yes, now it will only allow connections coming from the DevOps server. AWS security groups segregate what is public and private network, the internet from the VPC. The firewall of the instance itself will manage the ACL-like type, allowing certain types of ports from certain sources. More specific, I do inside the instances and I manage with Ansible. I think it makes sense for me. So the other thing is upgrades. Let's show how it looks like. Let's do just for the XDR for now. Limit. What did I do wrong? 5 xdr.pro.vpc. I can create aliases, so whenever I just say this short, like XDR or DNS, it understands. Maybe later. Yep. So it skipped because it was a dry run. It skipped, but now that's the for real run, it will run. Fast forwarding because it took some time. It did the apt update, apt upgrade, accept everything, and it's there. Let me get out of the menu and edit my inventory file again, because I want to add some aliases. Hope it's right. Let's run the same 5 to upgrade. Let me upgrade DNS now. Yep,
Now the short names, the aliases also work. While it's upgrading the DNS server, let me go to any other, for example this. Now we have this rule that only allows connections from this server, but the other was not removed because I created it after, so it created a new one instead of modifying the previous one. That's what I expected, and I came to check, and I should have anticipated before I run the playbook, but lesson learned. Delete, I think, I don't remember, number 1. Yeah, number 1 is gone. I can also remove number 3 because I don't have any IPv6 in here. Looks good. I will manually do the same changes to the others offline. Nobody deserves to watch that. Okay, the upgrade just worked for the DNS server, and that was a great reminder that the automation is only as good as the programmer, and doing things in baby steps, confirming it's doing things properly. Yeah, it's a good thing. So let's upgrade the VPN now. If you look into the code of this playbook, you will see that whenever it's a Red Hat Enterprise Linux derivative like CentOS, Fedora, whatever, you name it, it has a different task, different job for that because it uses DNF, YUM, RPM, and not the apt like Ubuntu Debian based instances. So this playbook's kind of flexible. Just finished. What are the others that I can do? For example, apps number 2. In all of them, what apps going to do is it will install a agent called Prometheus Node Exporter. This will be used later when we try to gather the health metrics of the servers into a monitoring system and watch with Grafana. Yep. It failed this part just because it failed to start or enable a service that doesn't exist. It was a dry run. And it's complete. Let me connect to any of these servers to see how good the job was done. So Prometheus Node Exporter is running on this port. I can check. Yep. And actually it says go to metrics to gather the metrics. This is what Prometheus will be scraping every so many seconds. Cool. What's the network, the private IP of this. It does allow connection from anywhere. I could set here the IP of the server, the monitoring server that I don't have yet. So I will leave as from anywhere. And I can do same metrics metric. Oh gosh. Oh, yep, forgot the port. Because port 80 is the pi hole. Yes, it does work. Yeah, that's pretty much what it is for centralizing the management of all the servers from a single location. I put these lines in yellow just to say it is not free, like free traffic like the green ones that people would connect to the VPN and reach the servers and get the requests served, but it's only for SSH, which is a cryptic protocol, gives a lot of access by nature, and is only allowed when coming from the DevOps server. When we deploy the DevOps server and we ran Ansible playbooks from the template, we ran the playbook called apps, which is something common like what are the apps that I want to have installed in all the servers. For example, I want to make sure that Nano is installed in all the servers. And the app that was already in the playbook was Prometheus Node Exporter. It's one agent that runs in each host, and when queried on port 9100, it will return a list of metrics. This is meant to be consumed by Prometheus. Prometheus is a scraper that will always polling and scraping the metrics from the monitored hosts. There are other monitoring systems that do other way around. The monitored hosts push their metrics to the server. In this case, the monitor server pulls all the metrics. Yes, we will deploy and install Prometheus and Grafana, and we will start watching the metrics in the servers. Of course, from the VPN cluster, we will monitor just the always on. The ephemerals don't really matter. And because of the load balancer, we assume they might have pretty much all the same load, just monitoring one of them. We might have one idea of what's the load in the others. And we are not monitoring the DevOps server. That does not allow any inbound traffic at all. I will call it monitor. I will use Ubuntu as my base image again. I will use 83 small instance type, which is again burstable and has 2 virtual CPUs, 2 gigabytes of RAM. It's a bit slow. I'm getting there. Oops. No key. I will add the key for Ansible later manually. Okay, This has to live in a private subnet for better security, and there's no reason to have a public IP in it. I could deploy it in either one subnet, a private subnet 1 or 2, and I will deploy in one just to keep everything in the same page for my diagram. But this is the type of application that could easily be deployed on the other availability zone. Because imagine if you have one application and the application and the database are in different availability zones. Either of the availability zones that go dark, the application is down. So we have actually a double single point of failure. Both availability zones affected will affect the application. So we keep both together. But this scraper, the health monitoring system, is not part of the production. It's not producing any work to serve the clients. Now we have a production infrastructure, one intranet that has VPN, it has ad blocks, it has one XDR, we have centralized management with Ansible on the DevOps. The monitoring could be on the other side and do not affect production, do not affect any of the services being served to the clients. Security group, default. It's very flat network, by the way. It's a very flat network for sure. I give it 20. I will not monitor too much in this disposable test environment. I would ideally suggest to have a secondary drive for the data of the database, for the metrics themselves. So in case the metrics fill the whole drive, doesn't crash the server in the root disk, the root volume. To save your time, I connected offline, created the Ansible account, and install Prometheus with this command here. Here. That's why now it's already there. So it installs Prometheus, that's the scraper. Install the node exporter in itself so it can monitor itself, and push gateway plus alert manager. We will see them later. Prometheus YAML. Here is the inventory of the hosts being monitored. We have here a job name called Prometheus, which is itself every 5 seconds it scrapes for the metrics, and it looks at the local host on port 9090 and on port 9100. Here in node, I will add more nodes. I will add one for the DNS, one for the XDR, one for the VPN. They will be forgot the ports. 9100. Looks right. I think so. So sudo systemctl
stop Prometheus. Then start it again. Hope it's now already scraping status. Is scraping the monitored nodes. Yeah, seems to be active. I will install Grafana. Grafana has a bit more into the installation. So I have to install these dependencies: app transport HTTPS, software property common, and wget. I will use wget to get the key for the PPA repository. I will add the key to the location. Then I will update apt database, install Grafana, start, enable, check the status, and also open port 3000 because that's the port of the web UI. All of that said, it is up and running and the rule was added to UFW. That is not enabled yet, but that's fine. When we enable, this will be not blocked. Let's create one target group because we want to add this web application on the application load balancer. It's going to be monitor target group. Is it HTTP or HTTPS? Don't remember. Yeah, I just checked and it's HTTP. Let's leave port 80. Then I will add the monitor, port 3000. I make some changes to the health check parameters. 2 successful means already consider it as healthy. Any status between 200 and 400 family is successful. Load balancer, AOB, port 443, rules. Let's add a rule that will be called monitor.prod.dft.1. And the host header is equal to this. This is the condition. Traffic goes to monitor target group. How about 103? So it's the third in the list. Good. If I go to the target group now, as soon as I added, I registered the tag, the target. It was in unused because the target group was not in use, so it was not even checking for the health. As soon as there is a rule that's attached to this target group, it goes to initial state because it's trying to see if it's healthy or not, and then assumes that it's healthy. I speed it up, reducing the amount of tentatives. Let's see. What was the address I said? This. Right there. Let's leave this here for now. I will go to Route 53 because I want to give a internal name for this box. so Ansible can reach it. Oops, not here. This IP. So I just added this. Copy here. Let's go to DevOps. Switching to my service account. Now I will edit the inventory of Ansible. Oops. Tabs instead of space for better looking. So I will run the audit there. This server is called Monitor. The password to elevate privileges. Yeah, first time. SSH always asks for confirmation. It's doing the firewall, it's doing the time zone. That was the dry run, now it's for real. All good. Let me also upgrade monitor. Make sure the server is in the up-to-date state. Let's run it. Finished. So now admin is the default password. It will ask you to change in the first login. I did login while I waited for the upgrades to happen. I will import a dashboard because there's no dashboard. We can't visualize data with no dashboard. So we go to Grafana and we search for dashboards depending on the type of a data source that you have or the panel type. It's sorting, so this is the most downloaded one, as you can imagine. Categories. This is the good thing if you want to monitor AWS resources, Azure, Docker. For now, I will just get this one here. I will check the number. The number is 1860. Back to import. I add here 1860. I have to select the data source, which is Prometheus, and that's it. So last 24 hours is too much. We are monitoring for just a few minutes. Here the hosts, for example, the XDR. Nothing really interesting happening anywhere, but at least you can see that network, disk space, CPU and memory everything is very nice looking and easy, natural to find information that you need about a host. I think it's configured for every 30 seconds to pull new metrics, so it's very granular. You can reduce it to up to a second. I think that's as fast as it can go, and it's crazy the amount of data you can acquire doing every second. I don't think it's smart. 5 seconds maybe. Yeah, that's pretty much what it is for this demo. All the servers are being monitored. Let's go back to the diagram. Here it is. We successfully deployed a monitoring server using Prometheus and Grafana that monitors the hosts except the most secure one that has no inbound connections at all. We also ran the Ansible playbooks to configure it, time zone, host name, firewall, and a few other stuff. It's time to secure our infrastructure. We have already deployed the XDR, which is called Wazuh. I can't say this. I will continue to say Wazuh, so forgive me for that. We have to install agents in all of the monitored hosts that will connect back to Wazuh and report the logs, the activities, and the XDR will make the work of analyzing and understand behavior for identifying malicious actors. Hope you have saved the password from the installation. Open the left menu and navigate to Server Management. First option, Endpoints Summary. Deploy new agent. In our case, is a Debian-based AMD64 architecture. This is the direct link, the direct name that any host inside the VPC will reach the server, which means I'm not making the connection through the ALB. I'm not giving it any name because I think it will assume the host name, and the default group will be enough. So this is the command we have to run. First, let me go to the XDR because we have to open a port number 1515. And I will choose one of the monitor servers, maybe the VPN. So this is the command that I copied, hitting enter. It's downloading this .deb file, this package. It's executing a command with these two environment variables, one for the address and one for the group. This is the command, the binary being executed to install the package that was just downloaded. After doing that, I will start enable. Enable means I'll restart on boot. And let's look at the logs. This is the location of the logs. Oops. Nothing there with error or warning yet. I can't do a tail minus F. And nothing is coming through, which is good. Okay, back here. Yep, it's here. Now I will do for the others and I will come back. I got them all registered and I have the problem of duplication for these two servers. The problem was caused by the Ansible playbooks that initially I was running with the fully qualified domains and then later I created aliases for these two here. So I ended up, after registering the 4 servers with 2 with different names than the others, they cannot be changed. So I renamed and I re-registered and I got duplications. I don't think I can delete them. Maybe after some time with no activity, they will be out of the range of window that we are looking for some things. I also Google and I realized that I allow connections to port 1515, but I also need to have connections on port 1514. 1515 is for registration and 1514 is for the connection. Right here, 14. I think I will have to give some time to see them establishing the connections.
As soon as port 1514 was allowed in the XDR, connections came in a few seconds. And as you can see, I actually found the solution in the official documentation for how to remove those unwanted previously registered agents. You do with one lowercase l first. We'll list the list that we already know and the IDs that we already knew, but then you can run with dr and the ID 001, 004 were the ones that I deleted. Thank God. Lesson learned. So I'm here actually on the next day because I had to give it time for routines that happens every so many hours or even every 12 hours that scrapes the system for vulnerable packages, for the logs looking for clues of maybe misuse of the system. I would say these are the two main or the two most interesting parts of this application. The security operations is more about compliance, and I have not much interest in this. But as you can see, PCI, GDPR, feel free to come here and browse and find important information for your compliance. This is where I prefer to live in because this gives me insights, telemetry of things that are happening inside the servers, the monitored hosts, like usage of sudo, disabled modification of tools, remote services. Anyway, I will not try to do any kind of analysis, but just pinpoint a few things. Like you may find what's the MITRE ID, which is more about TTPs, tactics, techniques, and procedures, and the rules that were tripped by those pieces of evidence. I say piece of evidence because might evidence something being misused or malicious intent action, but might not. But could be simply system admin work, right? We go into the system, we modify system, and these things trip wires and start alerting. We did not set up any email or notification means. Everything is in here. As you can see, there are plenty of things to poke around and find to silence what is false alarm and what is not. So at least nothing critical. This is just default base image of latest Ubuntu. One of them is not exactly the latest, but still. But there are many highs. I would go only here, and this is something for whenever there is spare time, which means never. This is looking at packages installed on the operating systems and correlating them with CVEs. Doesn't mean that if there is a CVE attached to it, it is vulnerable immediately. Might be, depending on the configuration. Maybe the version of one package is vulnerable for certain attack if you have it configured in certain way using certain features. So yeah, I would do some triage going this way. MITRE ATT&CK framework is more about behavioral, would see patterns of different commands being issued in the terminal, for example, that would indicate someone is enumerating resources or enumerating vulnerabilities. And I did not do any integration with VirusTotal, which is great when you have a directory, a user directory, a user volume that people place files there, like a shared volume, for example, and then you can specify certain types of files to be hashed, and this hash is sent to VirusTotal to check if it's known and malicious, any kind of malware or something like that, or even sending the file itself, which could be tricky because maybe it's a shared folder, a shared drive that sends may end up sending sensitive files with sensitive information to VirusTotal. And once it's in there, whoever has access to VirusTotal, which means anyone who pays the subscription, has access to open files that were sent to it. Okay, I think it's good enough to finish the walkthrough around how to defend our infrastructure with one XDR, monitoring host, telemetry, behavioral, and vulnerable packages. I updated the diagram to more precisely reflect the infrastructure that we just deployed. I hope the diagram is not too confusing, but what it means is that no matter which of the application load balancers will receive the call, they will always be able to reach the destination from the target group. But we don't have any high availability really. We could have redundancy. For example, I could clone the DNS server to the other availability zone, add it to the target group, and clients would be able to not only resolve in the availability zone that they are connected to, but in the other as a failover if that happens. But for now on, what I want to do is I want to deploy a truly high available set of applications. The applications themselves are not very important. What really matters is that, for example, Kubernetes, which is one amazing orchestrator for containers, will take care of terminating, replacing, and proxying, load balancing the traffic among the workers. The Kubernetes that I will deploy will be a single node, but could be a cluster of multiple nodes. Doesn't make any difference after deployed. The CI/CD pipeline will work exactly the same way. I might be deploying one server for the CI/CD like a build and release server, but this could actually be a container inside the Kubernetes cluster. I will keep it out just for the sake of visualization and the diagram. I will stop all of these instances because they are not relevant from now on, not just yet destroying them. I will leave just the VPN, and now it will look more like this. We are not looking at what's going on availability zone A. It's not relevant for the Kubernetes orchestration or the CI/CD pipeline if we have any of these other services. And I will even pretend I am connected to this availability zone, which doesn't really matter either. Okay. I will call this first instance as, guess what, Kubernetes. I will use Ubuntu as my base image, and I will point out that I have tutorials about how to deploy K3s, Minikube, and MicroKHS. By far, MicroKHS is the most integrated with the operating system, with Ubuntu itself, because it's canonical solution for Kubernetes. It's a single command. There is no competition for such a simple thing. And after the cluster or the node for Kubernetes is deployed, doesn't really matter much what is under the hood. In this case, it will be MicroKHS, but could be any of the others. Everything is the same. The API works the same, and we will be using kubectl no matter what. I will use private subnet too, just because I want. No public IP. And that default security group as always. I will give it a bit more space because I will be creating images and stuff and using the repository inside of MicroKHS. And what else? So far, the AWS network is very flat. Even though it does not allow any broadcast message, there is no termination protection. There is no collision domain. Sorry. my brain got wiped. There's no collision domain in broadcast. AWS takes care, the virtualization takes care of everything. And the firewall inside of each instance is responsible for taking care of the minimum, the refined communication ACL-like authorization. It's hard to speak, type, and click at the same time. Forgive me. Let's install MicroKHS. Oops. And snapd, I think. Because the installation of MicroKHS comes from snap, so we install snapd first, which is the daemon for snap, which is a package manager developed by Canonical, very natively integrated with Ubuntu, with very nice features. A lot of people hate it. Not everything is perfect, but I understand the point. There is App Armor integration. There are many other cool things on it that are valuable for the security point of view. Yeah, that's the only command to install microKHS. Nothing else. Took about 15 seconds. What I can do now is I can check if it's working. Probably I need to have sudo for that. microkhs.inspect. Do I? No, I think for inspecting. It's good. Okay. I've seen this happening before and doesn't affect anything at all. Sure, never search why. Is it maybe because I don't have privilege to go into that part of the system? No. Okay, so microKHS has kubectl integrated with it, so I could, for now, I'll use like this, and you get the nodes. Yeah, there's a single node, 53 seconds up. I can, for example, check for the services. I did not deploy any, but the system has default services that come with it as you deploy. In this case, there is one. I will enable the dashboard and will be easier to visualize how things are inside the cluster if we have a web UI for that. So I will copy paste few commands to save everybody's time. So I am enabling the dashboard. Right after that, I will enable the registry so I can have the images in it. I don't have to use Docker Hub, for example. I can use something local. I can enable the ingress, which is going to be one very important fundamental tool for routing traffic, inbound traffic. I will enable DNS. Yeah, I think for now that's it. Let me see if the dashboard is already working. First, I will get the IP of this machine. What's the IP? Here. 60.164. I'm in another terminal. I'm just pinging to, yeah, I do have connectivity. So HTTPS here. It's not port 443, but I will just hit enter. Just leave it here. Is it? I don't think so. Okay, this is the ingress. Because there is no application running, there is no route. It's fine. Leave the way it is. But for the dashboard, what we have to do first is we need to have a token. Okay, I will copy this token. This will be my authorization. By default, this token lives for an hour. There are ways to make it last longer if needed. Let me see. I have here a command that will do a port forward for the dashboard that's only local on port 443 to be available on port 10443 from outside. Okay, I leave it there. Now I will come back here and I will say 10443. Nope, not work. It's only listening on No, it's forwarding to localhost this. What did I do wrong? How can I have it from anywhere? I think it's somewhere around here. Is it? Nope. I think there is a flag to bind. Something like this. Otherwise it only binds on it was only binding on localhost. Of course, from outside I can't, but now it binds everywhere. HTTPS. Is it the schema? I think it is. Okay, here is where I paste that token that I created. Just leave the first option, enter the token, sign in. Voila. I will put all namespaces so I can see the resources that were created by default when microKHS was deployed. It has a few things, not any of our applications yet. We didn't deploy anything, but it comes with services like the ingress is using Nginx. We saw when we entered this IP here on the default port, which is 443. We saw this. This is Nginx, which is the ingress we will use later. What else can I say? The registry is here. The dashboard that I enable and I'm showcasing. Oops, too fast. DNS is something fully integrated with Kubernetes, is the ability of understanding the names and resolving them automatically. Okay. I will make this dashboard run as a service because we are doing tests. It's not a real production thing, and I want to keep it always open so I can always come back to it. The method that I will use is I will create a service that systemd will manage this application. It will be enabling port forwarding the Kubernetes dashboard. I put here as a description. It has to come after the network is available. We'll execute this script that we will create. We'll always restart. We'll run as root. Super dangerous. It's just because it is a demo and I want to keep my life less complicated as possible. Now I will create that file, that script. Okay, sudo. Yeah, I'm created inside the root directory. And I will paste the commands here. What it's gonna do is it will invoke bash. It will use AppArmor to allow it to exist. It is something that I had to add before in other environments because microKHS I was running in nested containerization. Maybe it's not really needed in here, but that's fine. I will make sure that microKHS will be started. I will give it some time to load, and then I will enter that command that will expose the dashboard on this port in any interface. Another thing I have to do is make it executable. Is there anything that I'm forgetting? Probably not. So what I will do is I will reload systemd and I will execute kubectl. That's the name. It's not really kubectl. I gave the name for the server as kubectl. Why not? Okay, gotta run it with sudo. This is all in my tutorial if you want to find all of these comments, copy paste yourself. switch to root before because I didn't add sudo before everything. Now I will reboot. No, before I reboot, let me check, and I reboot, make sure it will come up. Oh, it has 30 seconds delay. Yeah, it is in the sleep state. In some point it will be up. Maybe now. Yep, it's here. I quickly reboot, just make sure it was going to come up. The token is still valid. Yes, it is. It's valid for 1 hour. Now what we want to do is I will close this and I will deploy another server for the CI/CD pipeline where we will be running the kubectl commands from. So how can I call it? CI/CD will not be allowed. I think this slash. Let's see what it says. I will also use Ubuntu. Why not? The instance type will be maybe small. No key pair. Same subnet 2. Could be any. But same default subnet. Security group, sorry, 15 gigs. I will be producing artifacts, images. Will be built with Docker, and we might have some need for space. All of this time, I've been doing this manual deployment just because it doesn't really make any sense to use Terraform and automate deployment of something that will be deployed only once, or something that if it was in a real corporation infrastructure, even if it was static infrastructure, there's no point for automate what is static, in my opinion. So I'm doing everything manual and everybody can follow the steps. It allowed the name I gave. Good. Let me connect to it. And I will have to install kubectl here and pull the credentials from there to here. Let me download the binary for kubectl. It's here, so I will check it as executable. And let me echo what are my path, my system path. Because I want to move this file to a place that is in my path so I can call it from anywhere. User local. No. Okay. Let me copy. In fact, any place that is in my path will work. And I will put it there. I can call it from anywhere. Yes, I can. Now I gotta go back to the other server. Kubernetes, that's the one. and I want to export the configuration. Maybe I will need sudo, I don't know, microkhs config. Yeah, that's the configuration I need. This has all the credentials to connect to it, including the address and port where the micro KHS cluster single node is running on. I will get it here. I've saved here in a file. Let me say this. Let me create a .cube directory and move this micro into it with the name config. Is it right? So kubectl get nodes. Yes. So from the CI/CD server, I can issue commands as if I was inside. Same commands that I issued when I was there, when I was inside the Kubernetes server. Actually, let me go back to it. I want to do some changes to the firewall rules. So UFW is disabled. Before I enable, what I will do is I will not allow port 22 just yet. We will not be using Ansible with this, but I will allow port 443. I will allow port 10443 for the dashboard. 443 is for the ingress. And what was the port for kubectl? Is config 16443. 16443. I think for the registry is 32,000. Let me see if I continue to have connectivity. Yeah. Oh, I didn't enable. Sudo with enable. Yeah, looks like it's still working. One thing that I want to do is I want to use the application load balancer, so I don't go in it using just the IPs every time. I will create two target groups. Where is it? Target group. This will be actually, let me put the port here, 443. Customize those parameters a little bit. no underscore. So Kubernetes 443. The next one will be dashboard. On the same port. I could also use the application load balancer to be in front of the registry to give it a self-signed certificate, but what I will do later is I will configure my CI/CD pipeline to connect to the registry on port 32,000 without checking for HTTPS, allowing unsecure connection HTTP. Yeah, it's still in unused state because I'm not using the target group in any row yet. As soon as there is a row attached to it, it will start checking the health metrics. Then we'll go to initialization state. Nope. Add row. How will we call it? I will call Kubernetes. No, I will say for the dashboard I will use this. This is just the name, but I copy paste and I use the same name for the header condition, the host header condition when it matches. Then this will be sending to dashboard. Number doesn't really matter much. 104 will be the next in line. We'll give it a time, and I will make changes to the default because I don't really want to go to the ingress with no domain in it. What I want to do is whenever I have applications, and the applications will have names, domains, subdomains, it will we use the ingress to know what is the application that needs to go. So from the application load balance side is whatever doesn't match to any of these that have static manually created target groups with services running on them. This is going to be very dynamic. Anything else, like a wildcard, throw into the port 443 of the Kubernetes, because the ingress will take care of routing based on the host header in the nginx ingress to the proper application inside the cluster. Hope I'm doing it correct. Let me go here now and say this. Is it healthy? Yes, it is. Yes, it did. What about other addresses? Anything random, like dashboard, but let me replace the dashboard name with XYZ. Yep. Anything else is being routed successfully into the Nginx ingress of Kubernetes. Now it's up to Kubernetes to do its job. Okay, this target group. This. My session expired. It's fine. Okay. Now let's go and have some fun. GitHub. Let me find one of my repos that I have small labs for GitHub Actions. So for example, you can use Jenkins, you can use whatever tool you want, but I prefer using GitHub itself. I set up already, where is it? Actions. I already set up runners that can run, in this case they are containerized runners. I usually say one is the prod and one is the non-prod, because segregation of environments and they live in total different VPCs in the universe of cloud. But even in a on-prem infrastructure, they would live in segregated VLANs or in some way not reachable from the other environment. I explain a little bit what's going on here. It has the workflow set for the dev. I think I have a typo here. This should be prod. Yep, in fact. So if I go in here, for example, this is the workflow for when I have a non-production, a development environment. For example, it will look at pull requests that wants to merge into main, and the pull request is the trigger to use the runner in the non-production environment. Then just because it logs everything, I do a sanity check. I check that Docker works, and then this command will actually get the repo changes of the pull request. Just what I want to know is not the whole repository. What I want to know is what is the pull request changing. And then I have to do a lot of things here just to sort it out and identify what's being changed or added in the repo via the pull request. And then this is the part where changes are applied, which means it will do some build, create artifacts for the Docker image will be produced and push into the registry of the Kubernetes, the micro KHS, and we'll also apply the manifests if the files are manifests type. Anyway, I have some sections here because I have multiple examples here for multiple types of application, and for each one of them, not each one of them, at least two of them, they do have some exclusive parts where it looks for example, if it's something that runs inside the tunnel directory here, it has something exclusive that I will get something from Cloudflare, or if it is a GitHub runner for the CI/CD pipeline,
inside the container. It will also apply the credentials for GitHub. The difference of the dev and prod, non-prod and prod, is that in this case is when something is effectively merged or pushed into master, and then pushed into master will actually trigger a runner that runs into the prod environment, send it to check again, and same thing over and over, with the difference of the environment name that will be now everywhere. So this is what it is about the GitHub action. This demo is not about GitHub action, so I won't go there. And so I have here examples of applications. So I have uptype Kuma, I have GitHub runner, I have one sample of one Nginx type of application that would be, for example, a PHP application or something like that. Tunnel is actually a feature of a product of Cloudflare for zero trust. And yeah, I will leave like this, and also few tutorials links for these things. What I want to do with all of this talking is, let me get just one example here. I will try to manually make it work. You know what? I think I can clone this repo and just execute what I want. I think I might have to install Docker because it's not there by default. Yeah. Do I have Git? Yes, I do. GitHub Actions. Let me go into Nginx. First I will be the artifact. Yeah. So sudo apt update. Is it right? Hope it is. Let me check the IP of the Kubernetes server again. So this is it. Oops, not what I wanted to do. Oh God. Okay. So with that IP, what I want to do is I will docker build legacy deprecated. Okay, so what I'm doing here is I'm using docker build in the current folder. The tag is the IP. Would be better to have a host name here, the IP of the Kubernetes registry, and that port, Nginx, and oh gosh, stop scrolling, and registry is just any number. I could put here latest or whatever it is. It's pulling the dependency, it's following the Docker file configuration. I think it went successfully and built it. Let me sudo docker images. It uses a Debian bull.i base image for the PHP that I use in the Docker file, and I built mine on top of it. So it is huge, ridiculously
huge. So now what I will do is I will try to push it to, I'm gonna copy paste, try to push it to the registry. Okay, I made it fail. I mentioned this before. No, I did not, because it might fail due to the HTTPS thing. I gotta allow it to accept the non-encrypted connection here. This is one easy way to, for now, but in production I would actually make it proper and give it a certificate and everything. So the content of this will be a small JSON that will contain what is the endpoint that insecure registry is allowed. It's this. I think I have to reboot. Let me try, but I think I have to restart the Docker. Oh gosh. Yeah. Sudo systemctl restart Docker. Containerd. I don't remember. System, oh gosh, a typo here, so the autocomplete would never work. Okay, let's push. Now it's sending to the registry. All the layers. It's very interesting that container images, they are based on layers, and this is amazing for audit, for changes. You don't have to push the whole size of the image every time. You just send the change the layers. Let me see. I think it will take a while. It's not instantaneous. Let me create another token. Interesting. Yeah, just a bit slow. Where was I? I was here. I push the artifact. Yes. Okay. So what I will do now is I will execute, I will apply this what's the name? Manifest. Error when creating. Oh, because I have one environment in it. Nginx. I will manually place it because the pipeline would take care of it. Let me call it, I will call prod because everything is prod. and I'm not using the pipeline. I'm manually executing the commands. Okay, registry I think was the name of the tag I had just pushed. I could pause it, but I want to show that there is nothing that I will be doing extra offline than just this. Okay, prod.nginx, but actually what I will do is, this is the domain. I am not using .internal. For this lab, for this series of demos, I'm using prod.dft.1. Yeah, I won't explain what this manifest is doing, other than just saying it's creating the namespace, it's creating the deployment, which contains also the artifact and ports and health check configuration like threshold, timeouts, stuff. Then it creates a service that links to the deployment and one ingress that links to the service. And the ingress has the role that will look into this address here and properly route to the container. For now, I did the XYZ, but let me do nginx here just before I run and apply the manifest. Yeah, it says not found. We want it to be like this because whenever we run, if I did everything correct, yes, the namespace was executed in the very first, the failing execution. Everything else failed after that, so it was not changed, the namespace, but the deployment, the service, and the ingress was changed. Let me go again into this because I said I want to do something high available, and we will very soon apply 3 replicas. Let me go back here now, refresh this page. Let me find the namespace called nginx. Oh, we have something failing there. Let's see what it means. Deployment. It's using the name localhost. Localhost. I don't think it was called localhost before. I think it was called the IP of that server. Let me get it on the other screen. Maybe that was the issue. So I am at the same time applying the replicas to 3 and the artifact, the image is being changed. So unchanged, 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 only the deployment was changed. So we have the deployment, number of replicas. Now it's getting from this address, backoff, restart, failed, container. So the problem is the container itself is failing, not all the other components of the deployment, because I saw here this is nginx instead of 404. Now it knows where to route this address and it's routing to the pods of this deployment. The problem is the pods are failing themselves. So If I go there, I think I know what it is, because this Nginx application actually is just the shell. The application is not there. It is looking for something to run with this Apache installation. So how can we make it work? Back to the manifest. What was the volume that I used? So this deployment actually was mounting inside the container in var www html, which is the default location for Apache, the root directory for the hosts, the virtual hosts. This is the default one. It maps with a local path in the file system of the host that we don't have. Just to complete it, I will make it exist. I will sudo nkdir -p here, then I will go in it, then there's nothing there, of course, and I will touch. Now I will create one by hand. Index.php. In here we'll say works. Now how can I refresh it? Does it roll out as I expected to? Let's see. Oops, things are running now. Are them? Yes, it works. Let me take this out of the way. The reason why I had this manifest mounting the volume this way is because I have multiple examples here. In each one of them I have a different type of volume: persistent volume, NFS, I don't know. There are a few types here. I didn't pay attention that this one exactly was mounting something from the host file system, which in my opinion makes sense, because if I want 10 different replicas of this web server application running, I want them all getting the script files, the website, the PHP files from the very same location. So this way I am sure all the replicas have exactly the same level of application, same code, same version of the code. So yeah, it works. I could even output here the number, some identifier of the pod, and keep refreshing, and you would see the application load balancer routing the traffic to Kubernetes. Kubernetes would load balancing between the pods and would see the identifier of the pod being changed every time I press F5. But no, it's not a Kubernetes tutorial. I have some things broken. I will leave the way it is. What I need is this. I only have 2 out of 3. Maybe if I give some more time, it will come, the last one, or not. I'm satisfied with this demo. It's good to go. I hope you have followed and enjoyed and learned something from it. What we just did was creating some infrastructure where developers could go and deploy high available application orchestrated by Kubernetes with a CI/CD dedicated host capable of building artifacts, applying deployments, manifests to Kubernetes. I did not link it to my GitHub actions, but I have this public repository there that anyone can go there, see the examples and use them. And yep, call it as complete.